Going ahead with the next set of formulae. The first formula we are deriving is the formula for sine 2 theta. Now sine 2 theta can be thought of as sine of theta plus theta. Think of it as sine of A plus B. Sine of A plus B is sine A cos B plus cos A sine B. So expanding this will give you sine A cos B plus cos A sine B. In place of both A and B, we have theta and theta only. So sine theta cos theta plus cos theta sine theta. That simply gives you 2 times sine theta cos theta. So that's your first formula. That sine 2 theta can be written as 2 sine theta cos theta. Go ahead with the second formula. It's the formula for cos 2 theta. And expand it exactly like you have expanded sine 2 theta. Write that 2 theta as theta plus theta and cos of A plus B. If you remember, that was cos A cos B minus sin A sin B. So in place of A and B, we have theta and theta. So cos of theta plus theta will be cos theta into cos theta minus sin theta into sin theta, and that makes it cos square theta minus sin square theta. Now because we have a trigonometric identity that tells us that cos square theta plus sin square theta is 1, we can write cos square theta as 1 minus sin square theta, and then we have 1 minus sin square theta minus sin square theta that club together. If you just open up the bracket here, minus sin square theta minus sin square theta is minus 2 sin square theta, and that is why the formula for this becomes 1 minus 2 times sin square theta. So yeah, that's the expansion for cos 2 theta, and because you are replacing cos square theta with 1 minus sin square theta, you can also replace sin square theta with 1 minus cos square theta. So we will have yet another expansion, that is cos square theta minus sin square theta being written as 1 minus cos square theta. Open up the bracket, so it is minus 1 and plus cos square theta. Cos square theta plus cos square theta will be equal to 2 cos square theta, and then we have minus 1. So these are three expansions for cos 2 theta. So you can write cos 2 theta as cos square theta minus sin square theta. You can write it as 1 minus 2 sin square theta, or you can even write it as 2 cos square theta minus 1. Now from the last two formulae that you see here, that is cos 2 theta is 1 minus 2 sin square theta and cos 2 theta is 2 cos square theta minus 1. From these two formulae, we can make some rearrangement and derive some important kind of simplifications useful in our sums. So if we have cos 2 theta as 1 minus 2 sin square theta, we can take 2 sin square theta on the left and bring that cos 2 theta on the right. So we will have 2 sin square theta as 1 minus cos 2 theta, or let's write it as 1 minus cos 2 theta as 2 sin square theta. In a similar way, the second formula you had was cos 2 theta equal to 2 cos square theta minus 1. Just bring that 1 on the left hand side, and that will give you 1 plus cos 2 theta is equals to 2 cos square theta. Now these are two very important formulae that will be helpful in simplifications and how to use them. See, if it is 1 minus cos, you can write it as 2 sin square. If it is 1 plus cos, you can write it as 2 cos square. If there is a 2 theta here, there is a theta here. Same with this, if there is a 2 theta here, there is a theta here. Basically, when you apply this formula, the angle of 2 theta on the left becomes theta on the right. That is, whatever angle you have with the cos term here becomes half of whatever it is on the right hand side. Okay, so say for example, I ask you what is the value of 1 plus cos 16 theta. You will say 1 plus cos. 1 plus cos means I can write it as 2 cos square. The angle on the left, which is 16 theta, becomes half of whatever it is. That is, half of 16 theta will be 8 theta. So on the right it will become 8 theta. Okay, so 1 plus cos of 16 theta will be 2 cos square 8 theta. What if I ask you 1 minus cos theta? It is 1 minus cos, right? 1 minus cos means you can write it as 2 sine square. So 1 minus cos theta is 2 sine square something. That angle will be half of whatever you have over here. When this angle goes on the right, or when you apply this formula, the angle here becomes half of whatever it was. So here the angle will be theta by 2. If I ask you 1 minus cos of 150, so this will be 2 sine square, half of 150, that is 75. Now you should know how to apply this formula or this simplification, not only in the forward sense but also in the reverse sense. That is, if you are given cos square theta or sine square theta, you can eliminate that square and write both of them in terms of cos 2 theta. How can you do that? Take a look at this example. If I give you sine square, let's say 95, then what you can do is you can multiply and divide this with 2. So you can write it as 2 sine square 95 divided by 2. And you know that 2 sine square 95, 2 sine square theta was basically 1 minus cos of something. So this will be 1 minus cos of something, and that something is the double of whatever you have inside the sine square term. So inside sine square I had 95, so the angle here will be double of 95, which is 190. And do not forget this divided by 2, because whatever value you have written this value only for 2 sine square 95. The 2 in the denominator stays the way it is. So sine square 95 is 1 minus cos 90 the whole divided by 2. 1 minus cos of 190 the whole divided by 2. In a similar way, what if I ask you cos square, let's say 22 degrees. So cos square 22, you will first multiply and divide this by 2. 2 cos square 22, that can be written as 1 plus cos of something, and that something will be the double of this, that is 44. Because when you're going from here to here, the angle of theta becomes 2 theta, that is, it is becoming double when you're applying that formula in the reverse way. So cos square 22 is 1 plus cos 44 the whole divided by 2. Okay, that's how you can apply this additional set of formula that you have learned, and that additional set of formula is nothing but a simple rearrangement of the cos 2 theta formula. We continue with our formula. So now the third one is the tan 2 theta formula. Tan 2 theta, again we will write it as tan of theta plus theta. Tan of a plus b was what? It was tan a plus tan b divided by 1 minus tan a tan b. So in the numerator, if you check, you have tan theta plus tan theta, that will be 2 tan theta. And this tan theta into tan theta makes it tan square theta. So in the denominator, we have 1 minus tan square theta. Okay, that's the formula for tan 2 theta. Now think about it. What if I change the formula slightly? Okay, I am slightly going to change it, and you will observe that by simply changing a sign someplace in that entire formula, the formula becomes something totally different of whatever it currently is. So if I say 2 tan theta, see 2 tan theta upon 1 minus tan square theta, you can easily derive it and say that this will be equal to tan 2 theta. Okay, now what if I give you 2 tan theta upon 1? Instead of minus tan square theta, I am writing plus tan square theta. Let's check what that formula becomes. So 2 tan theta upon 1 plus tan square theta. This is like 2 tan theta upon 1 plus tan square theta is sec square theta. That sec square theta, see 1 upon sec square theta can be written in the numerator as cos square theta. So we have 2 tan theta into cos square theta. And tan theta also we will write it as sin theta upon cos theta. Cos theta and cos square theta get cancelled. So we are left with 2 sin theta cos theta. And this is where a bell rings in your mind and you tell me that, sir, 2 sin theta cos theta was the formula for sin 2 theta. I'll say you are absolutely right. And that is why 2 sin theta cos theta that we just got, we will write it as sin 2 theta. And check this. This is the formula for sin 2 theta. So sin 2 theta is 2 tan theta upon 1 plus tan square theta. to avoid confusion, the derivations are something that you should do in a very thorough manner, so that when two different formulae which are very identical, similar to each other, you can distinguish them very easily. So 2 tan theta upon 1 minus tan square theta, that will be tan 2 theta. But if the denominator becomes plus, then 2 tan theta upon 1 plus tan square theta will represent sin 2 theta. So this formula is, a formula for sin 2 theta can also be written as 2 tan theta upon, keep in mind, 1 plus tan square theta. You must know the entire simplification. 1 plus tan square theta becoming sec square theta goes to the numerator, becomes cos square theta. Right, tan theta is sin theta by cos theta. 1 cos theta gets cancelled, and then 2 sin theta cos theta is what we got, and that was the expansion for sin 2 theta. So here's the formula for sin 2 theta. It's 2 tan theta divided by 1 plus tan square theta. Let's go ahead with a similar formula. There was a formula for tan a plus b, right? A formula for tan a plus b. We have learned it in the last video, that tan a plus b, you can write it as tan a plus tan b upon 1 minus tan a tan b. I'm so sorry. Not tan a plus b, tan 45 plus x. If I give you tan 45 plus x, you can write it as 1 plus tan x upon 1 minus tan x. If I give you tan 45 minus x, you can write it as 1 minus tan x upon 1 plus tan x. Now I am giving you a similar formula. 1 minus tan square x upon 1 plus tan square x. You need to avoid confusion between the two formulae that I have written over here. This is a different formula, and the formula that we are deriving now is going to be a different formula. So the simplification we are trying to do is for this expression, 1 plus tan square x upon, 1 minus tan square x upon 1 plus tan square x. The denominator is sec square x. We can write it in the numerator as cos square x. That is multiplied by 1 minus tan square x. And we will write tan square x as sin square x upon cos square x. Expand the whole bracket, you have cos square x minus sin square x. And this is where you again jump with excitement and realize that cos square theta minus sin square theta was a formula for cos 2 theta. So check this out, cos square x minus sin square x, that's a formula for cos 2x. And yeah, we can write cos 2x in this manner, that is 1 minus tan square x upon 1 plus tan square x. Do not get confused with this identical looking formula. This formula was for tan 45 minus x, whereas here there's a formula we have just derived for cos 2x. So cos 2x can also be written as, because I'm using theta here, I'll say cos 2 theta. You can write it as 1 minus tan square theta upon 1 plus tan square theta. Okay, so these are certain formulae related to sin 2 theta, cos 2 theta and tan 2 theta that you've learned in the first set of formulae. Now there's an important simplification here that you should be aware about. See, whatever formula you have learned, say for example you learned it for sin 2 theta, it is 2 sin theta cos theta. How do you really apply this formula? It's not that you compulsorily need to have 2 theta here. You need to understand that when you are applying this formula, if the angle here was 2 theta, the angle here is half of it. So you can apply this formula with whatever angle you have, just that when you are applying this formula, the angle on the right will be half of whatever angle you have on the left. So say for example I ask you sine of 16 theta. You can write it as 2 sine half of this angle. So 2 sine 8 theta cos 8 theta. In a similar way, what if I ask you cos 2 theta or cos, let's not say 2 theta, let's say cos of 5 theta. Cos 5 theta, you can write it as 2 cos square. Keep in mind the angle here has to become half, because for the formula of cos 2 theta, we had a cos theta on the right. 2 theta became theta on the right, so the angle here will become half on the right hand side. So this will be 2 cos square 5 theta by 2 minus 1. What if I ask you tan 15 theta? you can write it as 2 tan 15 theta by 2 divided by 1 minus tan square 15 theta by 2. Okay, so that's how this entire concept is going to work. Let's go ahead with the next formula. This time the formula that you're learning is not for angles of the type 2 theta, but for angles of the type 3 theta. So for sine 3 theta, you can write sine of 2 theta plus theta. The derivation is identical, so we will go a little quick with this. Expand it by using the sine of a plus b formula. This will be sine 2 theta into cos theta, that is sine a cos b, plus cos 2 theta into sine theta. We can write sine 2 theta as 2 sine theta cos theta into we have cos theta. We have written sine 2 theta as 2 sine theta cos theta, and the cos theta that we already had, plus I want everything in terms of sine, so I will try to keep cos 2 theta in terms of sine only. So I will use the formula for cos 2 theta as 1 minus 2 sine square theta into we already have sine theta. Expand it further. This is already cos square theta, and cos square theta we can write it as 1 minus sine square theta. We are doing it because we want everything in terms of sine. Why is that so? Because we have the formula for sine 3 theta. So expand it, you will have 2 sine theta minus 2 sine cube theta, plus expand this, so that will be sine theta, and again minus 2 sine cube theta. Minus 2 sine cube theta minus 2 sine cube theta makes it minus 4 sine cube theta, and 2 sine theta plus sine theta, that makes it 3 sine theta. So here's the formula for sine 3 theta, that is sine 3 theta is 3 sine theta minus 4 sine cube theta, and this formula also, like the previous ones, can be applied in this way. The angle here is 3 theta, it gets divided by 3 when you apply this formula. So for example, what if I talk of sine 30 degrees? I know sine 30 degrees is half, but with the help of this formula you can write it as 3 sine. See, this angle becomes 3 times lesser on the right hand side. So here it will be 3 sine 10 degrees minus 4 sine cube 10 degrees. Okay, that's the formula for sine 3 theta. I will help you with I will give you a method later to remember this formula, but for the time being let's continue with cos 3 theta. I'll give you the method to remember the two formulae together. So if I talk about cos 3 theta, this will be cos of theta plus 2 theta, or 2 theta plus theta. Expand it, that will be cos 2 theta into cos theta minus sin 2 theta into sin theta. You can write sin 2 theta as 2 sin theta cos theta. But then sin theta get multiplied, that gives you sin square theta into cos theta. So we have 2 sin square theta into cos theta. We will write that sin square theta as 1 minus cos square theta into we had cos theta. Expand the bracket. So when you expand the bracket, you will have 2 cos theta plus 2 cos cube theta. And we need to go for a similar simplification here. Cos 2 theta, because we want everything in terms of cos, we will write it as 2 cos square theta minus 1 into cos theta. So when you expand the bracket, you get 2 cos square theta into cos theta, which is 2 cos cube theta minus cos theta. So 2 cos cube theta plus 2 cos cube theta makes it 4 cos cube theta, and minus cos theta minus 2 cos theta makes it minus 3 cos theta. So let's write that properly. The expansion for cos 3 theta, we just got it as 4 cos cube theta minus 3 cos theta. So that's the second formula that you need to remember. Now how to remember these formulae? See, the formula for sin 3 theta goes something like this. Imagine that in sin 3 theta, this 3 is traveling outside the sine. If it travels outside the sine, you get 3 sin theta Now, if there is a 3 sine theta, there are two 3's which are going to come, and the two 3's will never come together. That is, there is a coefficient 3 that you have, and there is a power 3 that you are going to have, but the power 3 and the coefficient 3 will never come together. Okay, so this will be 3 sine theta, because 3 has come as the coefficient, 3 will not be the power, this will be 3 sine theta only. The next term will have the power as 3, so it will be sine cube theta, and you need to remember that the coefficient will be 4. There will be a minus sign in the middle. Make sure to see that you're not skipping that point. There's a minus sign in the middle, okay? And now what about cos 3 theta? The formula for cos 3 theta is exactly the same as sin 3 theta, but you need to reverse it out. So 3 sin theta minus 4 sin cube theta. So 4 sin cube theta minus 3 sin theta will be the formula for this. But hang on, this is cos, right? So the terms here will also be with cos only, not with sin. So instead of 4 sin cube theta minus 3 sin theta, write it as 4 cos cube theta minus 3 cos theta. And that's the second formula you are learning. So these are two important formulae for sin 3 theta and cos 3 theta that you need to remember. Let's go ahead with the formula for tan 3 theta. You can write tan 3 theta as sin 3 theta upon cos 3 theta, and sin 3 theta and cos 3 theta. We just learned that sin 3 theta is 3 sin theta minus 4 sin cube theta, and cos 3 theta is 4 cos cube theta minus 3 cos theta. Now tan 3 theta, right? So we need all terms in tan theta, and sin theta and cos theta are terms that we need to eliminate. So what we will do is we will divide the numerator and denominator with cos cube theta. So in the denominator we will have 4 cos cube theta minus 3 cos theta upon cos cube theta. So when you separate the terms, the first term will become simply 4, and the second term will be 3 cos theta upon cos cube theta. You can cancel off one cos theta in the numerator and denominator. That will leave you with cos square theta in the denominator, and you can write it as sec square theta in the numerator. And sec square theta can be written as 1 plus tan square theta. So we have 3 into 1 plus tan square theta in the denominator. Expand the bracket, it will become minus 3 and minus 3 tan square theta. 4 minus 3 will be 1, and simply the denominator is what you have already achieved, that is 1 minus 3 tan square theta. Go for the numerator. In the numerator we have 3 sin theta upon cos cube theta. We will simplify that later. And 4 sin cube theta upon cos cube theta, that will give you 4 tan cube theta. What about the terms here? So we have 3 sin theta upon cos cube theta, right? So 3 sin theta upon, you can write cos cube theta as cos theta into cos square theta. Sin theta upon cos theta will be tan theta, and 1 upon cos square theta can be written as sec square theta in the numerator, and sec square theta can be written as 1 plus tan square theta in the numerator. So the entire first term here is basically 3 tan theta into 1 plus tan square theta. Expand it, so that will be 3 tan theta plus 3 tan cube theta, and then minus 4 tan cube theta. So plus 3 tan cube theta minus 4 tan cube theta makes it minus tan cube theta, and the numerator is what you now have as 3 tan theta minus tan cube theta. And this finally is the formula for tan 3 theta. Now how to remember this? It's like 3 comes out of tan and you get 3 tan theta. The 3 of coefficient and 3 of power will never come together. So because you already have a 3 in the coefficient, the next term will have 3 in its power. So the next term will be tan cube theta. Check out, you have a 3 in the power. There is a minus sign in the middle, and unlike cos and sine expansions, there is no 4 along with the cube term. Okay, so here's your numerator, 3 tan theta minus tan cube theta. Denominator, the first term will be 1, and the second term will be 3 tan square theta. There is a 3 here, but the power 3 will not have the coefficient as 3. 3 will come either in the power or in the coefficient. Because we have the power here as 1, the coefficient is 3. The power is 2, the coefficient is 3. But here already the power is 3. So there is no coefficient along with it, or you can say the coefficient is 1. Okay, in the denominator the first term will be 1. A very important thing to note down here is, if I say tan a plus b, then it was tan a plus tan b upon 1 minus tan a tan b. There was a plus in the numerator, minus in the denominator. If I say tan of a minus b, there will be a minus in the numerator and plus in the denominator. There is nothing as such for tan 3 theta. For tan 3 theta, if there is a minus up, there will be a minus only in the denominator also. Okay, so this is another important bunch of formula that you need to remember in trigonometry.